Here are your solutions to 4-9. This is Chapter 4, Lesson 9. Lesson 9 is qualitative graphs. And what a qualitative graph is, the graph shown is a qualitative graph. Qualitative graphs are graphs used to represent situations that may not have numerical values, or graphs in which numerical values are not included. The key thing to understand about a qualitative graph is that it's used to show the relationship between two things, just like any other graph on an x and a y axis. So for example, here we have percent downloaded and we have time, and notice there are no numerical values on either axis. That's part of the idea of a qualitative graph. But we can see that the percent downloaded from here to here had a constant rate of change, and then from the second point to the third point nothing happened, no downloads happened, and then the rate of downloading increased from point 3 to point 4. It was a steeper slope than from point 1 to point 2. And then of course nothing happened again, and then we went back to what looks to be a pretty similar rate to the first area here. Between these two here are about equal. That is the thing that I want you to understand about qualitative graphs, is that even though there are no numbers on it, we can see the relationships between, in this case, downloads and time, and we can tell that downloading was a lot more efficient right here than any other place in the graph, and that right here and right here there were no downloads taking place. So let's take a look at what this means with a few sample problems. For example number 1, it says the graph at the right displays the water level in a bathtub. Describe the change in the water level over time. So you can read this on your own, that's fine, but I'm going to just go through this by using the graph here. First of all, you can see that we have water level here, so the higher the value, the higher the level of water in the bathtub, and then of course on the x-axis we have time. So as time goes along, you can see that there's more and more and more water in the bathtub. But that's not the only thing you can tell. You can also tell that the water was filling the bathtub at a constant rate from here up to here. Then you can see that from this point to this point, we had no change. The water level in the bathtub remained the same. And then of course here we have a decreasing of the amount of water in the bathtub, and again we can also see that it increases as a constant rate. Just to give you an idea of what this might look like, let's say that we didn't fill at a constant rate. If what could happen is that the water in the bathtub is filled at a fairly slow rate at first, and then maybe you turned the water on and you walked away and you didn't want it to fill real fast because you weren't sure you'd get back in time. Then you get back and you decide that you want to get it full right away, so you turned it on and it fills at a high rate of speed. Then you get in and you realize you're in the bathtub for a little while and you realize that you could have put more water in. So after the level remains the same for a little while, 10 minutes later you decide you want a little bit more hot water, and you add a little bit more hot water, and then you sit in the bathtub for a while, and then when you get out, then it should drain at a pretty constant rate. But if you think about it, it actually would drain quicker in the beginning because there's more water, therefore there's more pressure forcing the water out, so it will drain quickest. And then if you've ever noticed toward the end at the bathtub, the water leaves less quickly because there's less water to push it out, so to speak. So actually you could see the filling and emptying of a bathtub might actually look like this graph here, and that gives you a little bit better idea of how to draw these qualitative graphs as showing the situation as accurately as possible. It's all about showing the rates of change. Here the rate of change was not that great because you weren't running the water real fast because you were out of the room. Here the rate of change was the steepest, etc. And then same over here, you have a slower rate of change here than you did while there was lots of pressure forcing the water out. Please press pause and do letter A. Okay, here's some more information you probably want to put in your notes and maybe on your gold sheet. Sketch qualitative graphs. Qualitative graphs represent the essential elements of a situation in graphical form. You can sketch qualitative graphs to represent many real-world functions that are described verbally, which is basically what we were just talking about in the previous problems. So now let's take a look at what this might look like in example 2. So here we are, example 2. A tennis ball is dropped onto the floor. On each successive bounce, it rebounds to a height less than its previous bounce height until it comes to a rest on the floor. Sketch a qualitative graph to represent the situation. So the first thing you need to do is draw the axes, label the vertical axis distance from the floor, and label the horizontal axis time, because we're going to input time, and over time we're going to have the bouncing ball a certain distance from the floor. Okay? So then it says sketch the shape of the graph. The distance from the floor starts out at a high value, so that's why we start up here. This is where the ball was at the beginning of the experiment. The ball falls to the floor. Now notice when the ball falls, it doesn't fall the same speed up here at the top of the graph as it's falling down here. Whenever you drop an object, it's accelerating toward the floor, so that's why we show this gentle curve at first and then turning into a steeper downward path, because it's picking up speed. And then the same thing, when it first comes off the floor, it bounces up fast, and as it comes up to this range, eventually, just for an instant, right about here, the ball is not rising or falling. It kind of just hesitates just for a split second there. So let me back some of this up so we can see this again better. So that's why we have different curves here on the graph, and that's very important to represent that. But you have to, but you're not going to show. If you think about it, the ball starts right up here, it drops straight down, it bounces straight back up to maybe here, and then it drops again, it bounces back up to maybe here, drops again, but everything would be in a straight up and down line. It wouldn't look necessarily like this, unless of course you toss the ball a little bit in that direction, then it would draw this path. But that's irrelevant to your graph. The graph, you need to understand, is all about time and distance. Okay, it's not necessarily showing the path. You could, like I said, drop a ball that just keeps bouncing up and down here until it eventually stops. Okay? One other thing I want to point out about this graph. First of all, as you can see, each successive bounce is less than the previous one until we finally get here. But one thing they said up here is until it comes to rest on the floor. I would say that they should have one additional thing here where you show that over a period of time the ball is at zero height. It doesn't just stop there. I would have continued this graph a little bit more to show that it comes to rest on the floor. All right, let's take a look at problem number 3. In this case, we have a child swinging on a swing. Sketch a qualitative graph to represent the situation. Now, as you can see, we're going to just skip to, first of all, you have to put distance from the ground here and time here. Time on the x-axis, distance from the ground. Notice it's from the ground, not total distance traveled or anything like that, which you could conceivably graph as well. We're going to do it distance from the ground in this case. And then I want you to see that it does not start out at 0, because if you think about it, if the child was on a swing set, okay, we'll make this real quick, the swing would be at this level here. It is not at the ground. So that's the reason that we start here. That's the first thing I'd like to point out. This one thing I would like to point out here is that it starts out at this distance here. So apparently they're thinking that you had pulled the swing back, and that's where we started swinging, because otherwise you wouldn't have a lower point here. So that's another thing you should notice from the graph. When the person pulled the kid in the swing back and then let the swing go, eventually the swing comes up this direction and it swings to its highest point. And also notice that each successive point gets a little bit higher as the child is gaining height and speed on the swing. But the one thing I want you to definitely notice here is, let's draw this up here. Let's say here is our graph. Notice that they didn't show that the swing went up and then back, like you would normally see a swing. This is kind of a difficult thing for many kids to see this relationship. It's always going in this direction. Time only travels in one direction. And we sometimes see students try to draw this graph, and then they realize that the swing, after the swing goes forward, the swing starts to come backward, and they want to do something that comes back in this direction, and then comes forward, and then comes back, and then comes forward, come back and forward, and things like that. There is no forward and back when it comes to time. Time travels in this direction only. So you have to think about where's the swing. Let's say a second after you start things, the swing comes up a little bit higher, and then the swing is going to dip down lower until it gets to the bottom point of swinging, and then it's going to be swinging forward, and as it swings forward, it's going to gain height to, let's say, this point here, a little bit higher than when it had come backwards, and then you're going to swing forward again. So the forward and backward is going forward in regard to time. Please press pause and do letter C.